Okay, we are in the last week of the 6 weeks, so there are a few things still to take care of. We're going to be finishing up geometric series today. In fact, arithmetic and geometric series today. You got your homework. This will be due on Friday, but I'm going to carry that over. It's going to be the first grade of the last 6 weeks. And speaking of the last 6 weeks, how many weeks do we have left in school total? Okay, if you include this week, because it's only Monday, we have 8 weeks. So 8 weeks including this week. So there is not a lot of time left. You remember next week we're going to be starting the STAR testing with English. Pick that up again in May. There's a lot going to be happening. But after we finish up everything today, I want to go ahead and give you time in class to start working on your assignment. If you have any questions you want to do together, we can do that. But tomorrow we'll start the binomial theorem. Hopefully we can finish that this week. If not, it'll be next week. And then we'll move on to conics for our last 6 weeks. But on Wednesday at the end, probably about the last 10, 15 minutes, we'll start the district assessments. Finish that on Thursday. We'll have the whole period for that. And another reason I wanted to make the homework due on Friday was because if you're not done with the homework by that time, if you finish on Thursday, you'll still have additional class time to look at the assignment so we can get that turned in. Let's see here. Focus activities. You will get your last focus activity number 4 tomorrow, and they'll be officially due on Wednesday. That is the last grade of the 6 weeks. I'm going to record it as a quiz, so please make sure to have those with you that day. If you need to look over here for a missing one, there should be some on the door, should be in the keyword. And then all classes, all retakes, outstanding assignments, anything of that nature must be turned in by Thursday morning by 8:05. So if you're wanting to retake the test from last week, if you still have the homework assignment out, anything of that nature, it all has to be taken care of by Thursday morning, the 4th, because at that time I'm going to start finalizing the grades. Any questions? Hey, man. I believe we have a late start next week. Yes, if you're not testing, I want to say it's 1:15 or 1:30. I'll look into that, but I know it's somewhere around there. And then we won't be seeing all the classes. Probably the first day we'll go ahead and do, I'm guessing, the morning 1 through 4th, and then the next day we'll go ahead and do 5 through 8. But we are testing 2 days next week, correct? English 1 and English 2, the 9th and the 11th? Pretty sure. And hopefully I'm correct about that. Okay. Any other questions? Hey, Zach. What's going to happen with what? Oh, so like what happens at the end of the school year? Well, early that week, you guys are going to have to take your finals early because the counselors have to finalize all your grades prior to graduation. And it's going to be more important this year because we are the first high school graduating at the Spirit Arena this year. Or I keep calling it Spirit Arena. What is it now? United Supermarkets? I'm going to call it Spirit. But we're graduating that Friday night. In fact, the very last day of school, the 24th. You guys won't be here, but we'll be graduating that night. So more than likely, if they go by years past, they'll have rehearsal on the 24th, probably in the morning, about 11-ish. Now, don't quote me on this. I'm just going off what we've done in the past. So I believe seniors only have to come Monday and Tuesday of that final week. And then Wednesday, Thursday, I think they have you come probably about 10 a.m. To the gym because there's some information they want to cover with you, let you know about rehearsal, what not to do at graduation, things like that. But yeah, so yeah, you do get out early. So basically you guys have a little over 7 weeks left and you're almost done. Okay. Anything else? Hey, Susie. I'm sorry? Wednesday, we're going to keep moving on with the binomial theorem, and then the last part of class, we'll start the district assessment. So are you here tomorrow? Yes. Then you'll already have the notes that we're going to continue on Wednesday. Okay. Anything else? Okay. Then let's finish up this set of notes and get you working on your assignment. Excuse me. So the last item is to show you how to take a repeating decimal, and without the use of a calculator, go ahead and rewrite it so that we get an equivalent fractional value. So let's say I have this right here, 0.234, 234, 234, and it's going to continue forever. And I want to know what fractional value is going to be equivalent to that. Now, if you go ahead and look at the notes online, there is a strategy using the geometric series infinite sum formula that you can use to do this. I'm going to go ahead and show you the way that I was taught because I think it's very quick. We want to go ahead and start by identifying our value as some variable. So let's say x. X equals 0. That's supposed to be a 0. 0.234, 234, 234, dot, dot, dot. Okay. Now the next step is to go ahead and create an equation. Okay, so you're going to go ahead and say that this x equals, now on the coefficient, okay, you're going to go ahead and have to choose what coefficient you're going to place there based on the number of repeating digits that you have. Okay, because you'll see what I mean as soon as I say it. Because how many digits do we have repeating here in this decimal? 3. I'm going to say 1000x is equal to 234.234, dot, dot, dot. See, what I want to go ahead and do is isolate one portion of that repeating pattern using a decimal. So see, if I were to go ahead and divide through by 1000, it would take that decimal and move it right back over. So I'd have the original amount. Okay. So whatever coefficient you have here, it's not standard. The number of zeros is going to depend on the number of digits in your repeating value. Okay. Well, the next step is to go ahead and break apart this decimal here. So I'm going to say 1000x is equal to 234 plus the 0.234, and it keeps going. But we started the problem by saying that that decimal equaled what? Yeah, we started by identifying that decimal as some variable. It doesn't matter what variable you use, but now I'm going to use substitution. I'm going to take that decimal and plug in the variable we chose because we know x is equal to that decimal. Now from here, you just go ahead and solve a simple equation, okay, a two-step equation. If I subtract the x over, how many x's do I have? 999. X is equal to 234. And then I divide through, so x is equal to 234 999ths. Now, the last thing you always want to do is make sure that your fraction is simplified as much as possible. Here, there is a common factor, so if you were to investigate it, you should end up with 26 1/11ths. That should be the fractional equivalent to the 0.234 repeating that we started with. Okay. And we can easily go ahead and check that in the calculator. In fact, I think I might already have this pulled up. There you go. So 26 1/11ths, so there's the 0.234 repeating. Okay. So let me go ahead and give you another one of these. Okay. And let's see if you can tell me what the equation would be based on the pattern. You remember earlier in this lesson, I mentioned this when we first looked at it. It was problem A. It had 0.1 repeating. We were talking about if it converges or diverges, and I went ahead and gave you the fractional equivalent as 1/9. Well, let me go ahead and show you why it is 1/9. Let's say we have x equals 0.1 repeating. Okay. So I'm going to start by saying that x equals the decimal that I'm trying to equate as a fraction. Now, what would be the equation for the next step? I'm not going to use 1000x again. What am I going to do here? It's just going to be 10x. 10x is equal to 1.111 repeating. Okay. See, the reason on the previous problem we went ahead and used 1000, 3 zeros, was because we had 3 digits repeating. Here, I'm only going to use a coefficient of 10, 10, because we have 1 digit repeating over and over again. Okay. And if I were to go ahead and divide through by 10, this decimal moves right back over. I've got x equals 0.1 repeating. Okay. So what do I do now? Okay. So let's break this apart. So 1.1 repeating, I can say, is 1 plus 0.11 repeating. And now this is where the substitution comes in. We already previously identified that decimal as x. So 10x is equal to 1 plus x. And now we solve for x. What does 10x minus x? 9x is equal to 1, and we do get x equals 1/9, just like we did earlier in the lesson. I want to say that was somewhere around Wednesday of last week where we talked about that problem. Excuse me today, I got a little tickle in my throat. Okay. And you probably won't even need all the steps. If you're familiar with the pattern, you'll notice if there's only one digit repeating, your denominator becomes what? 9. The numerator is whatever you have repeating. Think about when we had 2, 3, 4, we ultimately ended up with 234 over 999. Okay, so if you recognize the pattern, maybe it's not necessary to run through all these steps. Has anybody ever been shown this before, how to get a fractional equivalent for a repeating decimal? No? Some have, some not. Okay, does it make sense? Would you like me to give you another one? Would you like to try one on your own? Let's try one on our own. Okay. What if I were to give you x equals 0.272727? It's just going to repeat. Okay. So think about what we've done on the previous two problems. If you feel you need to write it out, please do so. If not, think about what your numerator and your denominator would be. I'm going to write it out, of course, once I give you a few minutes or a little time. Okay, so you may not be done, and that's okay. I'm just going to go ahead and catch up to you. Can anybody tell me what would the second step be? What equation am I going to create to go ahead and separate one repeating pattern from the rest? Satish? Okay, he says 100x is equal to 27.2727, dot, dot, dot. Okay, now why do we use 100 this time? Yeah, there's only two digits that are repeating over and over again. That determines what you're going to end up. So we know immediately my denominator should end up being what? Now remember, this is before you're able to simplify. If possible, it would be 99. Remember when we did the one digit, we had a denominator of 9. When we had the three digit repeating, then it was 999. So I'm going to break this apart. 100x is equal to 27 plus 0.2727 dot, dot, dot. But we recognize that is the number that I initially began with. 100x equals 27 plus x. And then now we're just solving the equation. So 99x is equal to 27. So x is equal to 27/99. Now, in fact, this one will reduce to what? 3/11. There we go. Okay, so if we were to type 3/11 in the calculator, we should be getting 0.2727, and it's going to keep going. Questions? Anybody having problems with that? Any issues? Okay. All right, good, 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 good. Well, the very last topic of this section, it's not in your notes, but it's another concept that Mr. Heinrich asked that I go ahead and show you guys. So we're not going to spend a whole lot of time on it, but this is, again, for those people who are going into calculus. Okay. But probably not a bad idea for those folks who are not going into calculus. Go ahead and make sure to copy it down as well, but definitely those in calculus will see it again. So here's the idea. We've been working with finding the infinite sum of a geometric series, right? Okay. What was that formula? S equals what? For the infinite sum of a geometric series. Okay, so Aiden says a sub 1 over 1 minus r. Absolutely right. And there's a condition we need to have met in order to do this. The absolute value of r has to be less than 1. Okay. So the idea here is that given an expression that's already had the information plugged into this formula, we kind of want to work backwards. We want to go ahead and generate the series and then write it as a summation notation. We want to use sigma. So let's say I were to give you this example. I'm trying to remember the one off the top of my head because I don't have my notes here. I placed them somewhere. Let's do this. Let's say I were to give you 4 over 1 minus x. Where are my notes? Don't know where I placed them. So 4 over 1 minus x. So what you always want to do is compare this to the formula for the infinite sum of a geometric series. We have the first term over 1 minus r. So looking here, hopefully we're going to be able to identify what those are. Can anybody tell me what the first term is? It would have to be 4. See, that's my numerator. So this would be the first term. Okay. What does x represent? That's r. That's my common ratio. There we go. Now remember, we're going to go ahead and expand this as a series, so we're not going to be using commas. We're going to be adding these values together. Okay, so if the first term is 4, what am I going to add for the second term? Now remember, think about if you were just creating the sequence. This is the first term. In order to get the second term, I'd simply multiply it by the common ratio. So that'd be plus 4x plus, now 4x times common ratio. So it'd be 4x squared plus, now the third term times the common ratio to give me the fourth, 4x cubed. And then that pattern's just going to continue, right? Does everybody see what I'm doing? Is everybody okay with where I got those terms from? Okay, now we want to write that as a summation notation. Okay, so there's my sigma. We're going from the first term to infinity. Now what you're going to put here is the explicit form for a geometric sequence. And remember, that was really easy. We already know the first term in r. So the first term, 4, times x to the n minus 1. Excuse me. The only thing we need to go ahead and do is make sure we have a restriction for x. We have to say -1 less than x, which is less than 1. And can anybody tell me why we would have to have that restriction down at the end of that expression? Remember, what's the only way I can use this formula to begin with? If r is the absolute value less than 1. Now, I was trying to remember this earlier today. At the beginning of the school year, did we talk about solving absolute value inequalities? Did I show you that? I want to say yes, but I'm not 100%. I think I did, but I'm not, like I said, I'm not sure. Well, if you're trying to solve an absolute value inequality, like less than 1, you might remember that when you go ahead and solve it, this becomes a compound inequality. You put whatever's in the absolute value bars between the constant and its opposite. So -1 less than r less than 1. Here, we're just talking about x because that's the common ratio. Does that make sense? Okay. But there you go. That's what we refer to as a power series. Okay. So let me give you another example. Let's say 1 over 1 plus x. So try this one on your own. And remember, always look at the expression that you're given, okay, and realize that it has to look like the original formula for the infinite sum. So maybe something's going to be changing here. Okay, that's going to be my little hint to you. Oh, here it is right here. Yeah. Found my notes. And I've only got one more problem I'm going to show you after this, and then we can go ahead and turn our attention to the homework. So how many people think they have at least a good 3 or 4 terms for their series already mapped out? Okay, so here's what we should be getting. Let's see if we're all on the same page. So the first term is 1, but then I'm going to go ahead and subtract x. And then I'm going to add x squared. And then I'm going to subtract x cubed. And then I'm going to add x to the 4th. What did I do? Does anybody notice it? Remember, I gave you the hint that you want to make sure your expression looks like the original formula, right? So what's different about this expression? It's plus x. The formula always has me subtracting. So the only way that's going to change to addition is if the common ratio is, it's got to be negative. There we go. So this is actually 1 over 1 minus negative x. So you see the first term is 1, but then times negative x, times negative x, times negative x, and the pattern continues. Is everybody okay with that? How many people got that right? How many people noticed it? Okay. So the only thing you probably didn't get is just the negatives. Did everybody at least get the terms? Okay. So now let's go ahead and write out the sigma notation. Well, we're going to go from 1 to infinity. Okay, we're going to plug in our information. The first term, and you don't have to write the 1, but I'm going to go ahead and do so. What was r again? Negative x to the n minus 1. And once again, whoop, not equal to x less than 1. Now, something we didn't talk about a minute ago, why don't we have equality on those? What would happen if x did equal, like, say, a positive 1? There you go. We could end up potentially with an undefined situation. And I really should, if you put in negative 1, because this one here is positive, the 1 plus negative 1 is going to cancel out. Okay. All right, we ready for one more? Okay, let's try this one on our own. Let's try to do the whole thing. Now remember, again, this one's going to be a little trickier. Think about what the original formula looks like. Okay, so your last power series is 3 over 4 minus x. 3 over 4 minus x. So let's see if we can generate maybe the first 3 or 4 terms of the series and then write the summation notation using sigma. Hey. Put that in the tray, please, sir. Yes. Well, it was kind of your decision. We weren't talking about the test, so you're good to go. Unless you feel we're bothering you. But I mean, does math really ever truly bother anyone? Makes our day bright and shiny. Puts a smile on your face. See, look at Zach. Zach's got a big smile on his face. Okay. Would anybody be willing to come on up and show me what they got as far as the series goes? Ooh, a lot of hands. I just need one. No, let me at least ask you this question. Is there anything I would have to do to that expression before I generate the series? Yes. Okay. Do I need to use the random number generator? Okay. Then, unless anybody wants to come up. No. Okay, so we have 36 seats in here, so, I mean, it's only going to go to 34. I'll go to 34, because that's the last one. So nobody wants to volunteer before I click the button? Someone say I will? Oh, I guess I was optimistic. 16. Erica. All right. Erica says I'll do it. Okay, I'd like to thank Erica for volunteering. You need to go ahead and write out, generate the series, and then write the summation notation with sigma. Okay. And even if you're not sure, your classmates are going to help you out. Okay. There you go, man. Excuse me. Okay, so we'll start with the first term. We're not correct. I'm sorry. Somebody help her out. What's the first term and why? Why do we have to factor out a 4? There you go. The original formula always has 1 minus r, but now we have 4 minus r. Okay. So if we factor out that 4, then our first term is actually what? 3/4. 3/4. There we go. Now, also factoring out the 4, what would r become? What's going to happen to x if I divide that out? It would be x over 4. Yes, there we go. So the first term is 3/4. Oh, now remember, no comma. Okay. So the next one would be, oh. Now remember, the common ratio is x over 4. So to get the second term, we're going to multiply the first by x over 4. So that would be 3x over what? Oh. That's okay. 16. Now what's 3x over 16 times x over 4? There you go. Okay. And then you just continue that, right? Okay, so go ahead and put plus dot dot dot. Okay. The sigma notation? Okay. So we're going to infinity. We're starting at the first term. So now we can just write out the formula using the first and common ratio. So 3/4 times x over 4 to the n minus 1. Now, I will go ahead and tell you the restriction is not going to be between -1 and 1. What would it be this time? Aiden, say it louder. She says -4 and 4, and that is absolutely correct. Why? That's exactly right. What she's saying is that when we factored out the 4, we now have 1/4 x, but to get the original coefficient from the formula, if I were to plug in 4, the 1/4 and 4 would cancel each other and either give me 1 or -1 depending on sign. So that is absolutely correct. How many people got that right? Okay. How many people said the first term was 3 and went from there? Okay. All right, they can get a little tricky. Just always think about comparing your expression to what the original formula looks like. The first term over 1 minus r. Okay, we want 1, we want minus, all that good stuff. Okay, like I said, this is not going to show up on a quiz or a test as far as a problem that you can lose points for. I might go ahead and make it, like a bonus or something. Would you like that? Sure, okay. Or I'll definitely probably turn another one of these into a focus activity just so we can get a little more practice. But that is all I have for today. So let's take a look at the homework. Is there a problem on the homework you would like to work together? Oh, and I'm going to go ahead and tell you I talked about this briefly. I think you would be able to solve the problem, but I'm going to go ahead and omit it just in case. This one here, the expression is going to turn out to be quadratic. Do you remember in the very first section, arithmetic and geometric sequences, when I introduced you to the concept of first difference, second difference, third difference? That's what this problem is based on. And while I did talk about it, we really didn't go into it in a whole lot of detail. So I'm just going to go ahead and omit it. If you want to work the problem, if you feel confident, I can count it as a bonus when we grade it on Friday. Okay, we could do that. But that one I'm going to go ahead and omit because we'll see. Okay. So what problem would you like to work together? $27. Okay, so 27 is, that's what Christian says. You guys agree with that? Okay, I see a few people shaking their heads, so I'll go with it. Okay, now the problem says, in the figure shown at right, what fraction of the square is eventually shaded if the indicated shading process continues indefinitely? And that's a key word here. If it continues indefinitely. Is there any other word that I possibly could have subbed in there that means the same thing? Something that we were working on just a moment ago? There you go. If the indicated shading process continues infinitely. So we know this is arithmetic or geometric. This is going to be geometric, and because we specifically use that word, we can use this formula here. Well, it is geometric, but the question is going to be, how do we generate the sequence? If we can determine what the first term and the common ratio is, we got everything we need. Okay, so any ideas? What would the first term be? Now, how are we creating our terms? We're basing it off what? Okay, fraction of the square that's eventually going to be shaded. I heard someone say something. 1/4. So what are you saying? That's the first term or common ratio? Satish says both. He's absolutely right. Okay, so the first term would be 1/4, because look at the largest figure we have. Forget about the fact that this one is, continually going down. Only one out of the 4 original squares is going to be shaded. Okay, so my first term is going to be 1/4. But then the pattern is going to continue. Oh, that was weird. The pattern is going to continue within 1 square of that original figure. And then again in that figure. So what is the common ratio? Satish was correct. He said it's the what? It is 1/4 as well. Because kind of work backwards. Look at this smaller square right here. Okay, this pattern continues in 1/4 of the previous one. This one here is 1/4 of the previous one. So yeah, we're multiplying each by 1/4 if I were to generate it. We're just looking at this visually this time. But now that was the hardest part. Once we know those two terms, well, then we just plug it in. 1/4 over 1 minus 1/4. What's 1 minus 1/4? 3/4. Okay. And when we divide by a fraction, what do? We multiply by the reciprocal. So 1/4 times 4/3. So eventually, what fractional portion should be shaded of the figure? 1/3. And remember, we said before that's not a true sum, but it should converge to 1/3. Okay. And there we go. Now, I'll even go ahead and give you a hint on numbers 25 and 28. Number 25, just be real careful about the wording, because it does say at the end, find your salary at the start of your 5th year. So the wording is very important on that one. But numbers 25 and 28, they're just series where you're adding 5 terms together, right? So maybe on those, it's not really worth it to go ahead and come up with an equation that you could then plug in. Maybe it's just better to go ahead and actually generate the first 5 terms and just add them up. because there's only 5 of them. But ultimately, you can decide what you want to go ahead and do. Okay. The only other thing I want to go ahead and show you is if you go right back to number 1. Okay. It says write each sum using summation notation. So for numbers 1 through 4, we are not finding the actual sum. We just want that sigma notation. So this is what I've seen a lot of people doing today. I start out writing this, so we have the first term. What should be put up here? Or let me ask you, this is what I see a lot of people doing. Would 54 go right there? Why not? Because see, here's the thing. 54 is just the last term in this partial sum that I want to add. Okay, we don't know that 54 is actually the 54th term. Remember, that upper value is the term number you're stopping at. So one of the things you're going to have to figure out, and not just, the explicit formula here for the nth term, is how many terms are there in this partial sum from -6 all the way to 54. Okay. So again, not only defines your formula, but also define that. I would encourage you to use this guy right here. A sub n is equal to the first plus n minus 1 times d. Okay. All right. Okay, so I'm going to go ahead, give you guys some time to work on your papers, help each other out. I encourage you to do that. If you have any questions, let me know. I'm going to pass back papers I have.